The life of the mind, Hindu science, its religious origins, astronomers, mathematicians, the decimal system, algebra, geometry, physics, chemistry, physiology, Vedic medicine, physicians, surgeons, anesthetics, vaccination, hypnotism. India's work in science is both very old and very young. Young as an independent and secular pursuit, old as a subsidiary interest of her priests. Religion being the core of Hindu life, those sciences were cultivated first that contributed to religion. Astronomy grew out of the worship of the heavenly bodies, and the observation of their movements aimed to fix the calendar of festival and sacrificial days. Grammar and philology developed out of the insistence that every prayer and formula, though couched in a dead language, should be textually and phonetically correct. As in our Middle Ages, the scientists of India, for better and for worse, were her priests. Astronomy was an incidental offspring of astrology, and slowly emancipated itself under Greek influence. The earliest astronomical treatises, the Siddhantas, circa 425 BC, were based on Greek science. In Varahamihira, whose compendium was significantly titled Complete System of Natural Astrology, frankly acknowledged his dependence upon the Greeks. The greatest of Hindu astronomers and mathematicians, Aryabhata, discussed in verse such poetic subjects as quadratic equations, sine, and the value of pi. He explained eclipses, solstices, and equinoxes, announced the sphericity of the Earth and its diurnal revolution on its axis, and wrote, in daring anticipation of Renaissance science, "The sphere of the stars is stationary, and the Earth, by its revolution, produces the daily rising and setting of planets and stars." His most famous successor, Brahmagupta, systematized the astronomic knowledge of India, but obstructed its development by rejecting Aryabhata's theory of the revolution of the Earth. These men and their followers adapted to Hindu usage the Babylonian division of the skies into zodiacal constellations. They made a calendar of 12 months, each of 30 days, each of 30 hours, inserting an intercalary month every 5 years. They calculated with remarkable accuracy the diameter of the moon, the eclipses of the moon and the sun, the position of the poles, and the position in motion of the major stars. They expounded the theory, though not the law, of gravity when they wrote in the Siddhantas, "The earth, owing to its force of gravity, draws all things to itself." To make these complex calculations, the Hindus developed a system of mathematics superior, in everything except geometry, to that of the Greeks. Among the most vital parts of our Oriental heritage are the Arabic numerals and the decimal system, both of which came to us through the Arabs from India. The miscalled Arabic numerals are found on the rock edicts of Ashoka, 256 BC, 1,000 years before their occurrence in Arabic literature. Said the great and magnanimous Laplace, "It is India that gave us the ingenious method of expressing all numbers by 10 symbols, each receiving a value of position as well as an absolute value." A profound and important idea, which appears so simple to us now that we ignore its true merit. But its very simplicity, the great ease which it has lent to all computations, puts our arithmetic in the first rank of useful inventions, and we shall appreciate the grandeur of this achievement the more when we remember that it escaped the genius of Archimedes and Apollonius, two of the greatest men produced by antiquity. The decimal system was known to Aryabhata and Brahmagupta long before its appearance in the writings of the Arabs and the Syrians. It was adopted by China from Buddhist missionaries, and Muhammad ibn Musa al-Khwarizmi, the greatest mathematician of his age, circa 850 AD, seems to have introduced it into Baghdad. The oldest known use of zero in Asia or Europe is in an Arabic document dated 873 AD, 3 years sooner than its first known appearance in India, but by general consent, the Arabs borrowed this too from India. And the most modest and most valuable of all numerals is one of the subtle gifts of India to mankind. Note that outside of Asia or Europe, zero was used by the Mayas of America in the 1st century AD. Dr. Breasted attributes a knowledge of the place value of numerals as well to the ancient Babylonians. Algebra was developed in apparent independence by both the Hindus and the Greeks. The first algebraist known to us, the Greek Diophantus, 360 AD, antedates Aryabhata by a century, but Kajori believes that he took his lead from India. But our adoption of algebra's Arabic name, aljabar or adjustment, indicates that it came to Western Europe from the Arabs, i.e. from India, rather than from Greece. The great Hindu leaders in this field, as in astronomy, were Aryabhata, Brahmagupta, and Bhaskara. The last, 1114 AD, appears to have invented the radical sign and many algebraic symbols. These men created the conception of a negative quantity, without which algebra would have been impossible. They formulated rules for finding permutations and combinations. They found the square root of 2 and solved, in the 8th century AD, indeterminate equations of the 2nd degree that were unknown to Europe until the days of Euler, 1,000 years later. They expressed their science in poetic form and gave to mathematical problems a grace characteristic of India's golden age. These two may serve as examples of simpler Hindu algebra. Out of a swarm of bees, 1/5 part settled on a katamba blossom, 1/3 on a cylindra flower. 3 times the difference of those numbers flew to the bloom of a kachaja. 1 bee, which remained, hovered about in the air. Tell me, charming woman, the number of bees. 8 rubies, 10 emeralds, and 100 pearls, which are in thy earring, my beloved, were purchased by me for thee at an equal amount. And the sum of the prices of the 3 sorts of gems was 3 less than half 100. Tell me the price of each, auspicious woman. The Hindus were not so successful in geometry. In the measurement and construction of altars, the priests formulated the Pythagorean theorem, by which the square of the hypotenuse of the right-angled triangle equals the sum of the squares of the other sides, several hundred years before the birth of Christ. Aryabhata, probably influenced by the Greeks, found the area of a triangle, a trapezium, and a circle, and calculated the value of pi, the relationship of diameter to circumference in a circle, at 3.1416, a figure not equaled in accuracy until the days of Purbach, 1423 to 1461 in Europe. Bhaskara crudely anticipated the differential calculus. Aryabhata grew up a table of sines, and the Surya Siddhanta provided a system of trigonometry more advanced than anything known to the Greeks. 2 systems of Hindu thought propound physical theories suggestively similar to those of Greece. Kananda, founder of the Vaisheshika philosophy, held that the world was composed of atoms, as many in kind as the various elements. The Jains more nearly approximated to Democritus by teaching that all atoms were of the same kind, producing different effects by diverse modes of combination. Kananda believed light and heat to be varieties of the same substance. Udayana taught that all heat comes from the sun. And Vakaspati like Newton, interpreted light as composed of minute particles emitted by substances in striking the eye. Musical notes and intervals were analyzed and mathematically calculated in Hindu treatises on music. Reference the Ocean of Music, Samgita Ratnakara, of Sharamgadiva. And the Pythagorean law was formulated by which the number of vibrations, and therefore the pitch of the note, varies inversely as the length of the string between the point of attachment and the point of touch. There is some evidence that Hindu mariners of the 1st century AD used a compass made by an iron fish floating in a vessel of oil and pointing north. Chemistry developed from two sources, medicine and industry. Something has been said about the chemical excellence of cast iron in ancient India, and about the high industrial development of Gupta times, when India was looked to, even by imperial Rome, as the most skilled of the nations in such chemical industries as dyeing, tanning, soap making, glass, and cement. As early as the 2nd century BC, Nagarjuna devoted an entire volume to mercury. By the 6th century, the Hindus were far ahead of Europe in industrial chemistry. They were masters of calcination, distillation, sublimation, steaming, fixation, the production of light without heat, the mixing of anesthetic and soporific powders, and the preparation of metallic salts, compounds, and alloys. The tempering of steel was brought in ancient India to a perfection unknown in Europe till our own times. King Porus is said to have selected as a specially valuable gift for Alexander not gold, not silver, but 30 pounds of steel. The Muslims took much of this Hindu chemical science and industry to the Near East and Europe. The secret of manufacturing Damascus blades, for example, was taken by the Arabs from the Persians and by the Persians from India. Anatomy and physiology, like some aspects of chemistry, were byproducts of Hindu medicine. As far back as the 6th century BC, Hindu physicians described ligaments, sutures, lymphatics, nerve plexus, fascia, adipose and vascular tissues, mucus and synovial membranes, and many more muscles than any modern cadaver is able to show. The doctors of pre-Christian India shared Aristotle's mistaken conception of the heart as the seat and organ of consciousness, and supposed that the nerves ascended to and descended from the heart. But they understood remarkably well the processes of digestion, the different functions of the gastric juices, the conversion of chyme into chyle, and of vis into blood. Anticipating Wiseman by 2,400 years, Atreya, circa 500 BC, held that the parental seed is independent of the parent's body and contains in itself, in miniature, the whole parental organism. Examination for virility was recommended as a prerequisite for marriage in men, and the Code of Manu warned against marrying mates affected with tuberculosis, epilepsy, leprosy, chronic dyspepsia, piles, or loquacity. Birth control, in the latest theological fashion, was suggested by the Hindu medical schools of 500 BC in the theory that during 12 days of the menstrual cycle, impregnation is impossible. Fetal development was described with considerable accuracy. It was noted that the sex of the fetus remains for a time indeterminate, and it was claimed that in some cases the sex of the embryo could be influenced by food or drugs. The records of Hindu medicine begin with the Atharva Veda. Here, embedded in a mass of incantations and magic, is a list of diseases with their symptoms. Medicine arose as an adjunct to magic. The healer studied and used earthly means of cure to help his spiritual formulas. Later, he relied more and more upon such secular methods, continuing the magic spell, like our bedside manner, as a psychological aid. Appended to the Atharva Veda is the Ajurveda, the science of longevity. In this oldest system of Hindu medicine, illness is attributed to disorder in one of the four humors: air, water, phlegm, and blood. Treatment is recommended with herbs and charms. Many of its diagnoses and cures are still used in India, with a success that is sometimes the envy of Western physicians. The Rig Veda names over 1,000 such herbs and advocates water as the best cure for most diseases. Even in Vedic times, physicians and surgeons were being differentiated from magic doctors and were living in houses surrounded by gardens in which they cultivated medicinal plants. The great names in Hindu medicine are those of Sushruta in the 5th century before and Charaka in the 2nd century after Christ. Sushruta, professor of medicine in the University of Benares, wrote down in Sanskrit a system of diagnosis and therapy whose elements had descended to him from his teacher Dhanvantari. His book dealt at length with surgery, obstetrics, diet, bathing, drugs, infant feeding and hygiene, and medical education. Charaka composed a Samhita, or Encyclopedia of Medicine, which is still used in India, and gave to his followers an almost Hippocratic conception of their calling. Not for self, not for the fulfillment of any earthly or desire of gain, but solely for the good of suffering humanity should you treat your patients, and so excel all. Only less industrious than these are Vagbhata, 625 AD, who prepared a medical compendium in prose and verse, and Bhava Misra, 1550 AD, whose voluminous work on anatomy, physiology, and medicine mentioned, 100 years before Harvey, the circulation of the blood, and prescribed mercury for that novel disease syphilis, which had recently been brought in by the Portuguese as part of Europe's heritage to India. Sushruta described many surgical operations: cataract, hernia, lithotomy, caesarean section, and more, and 121 surgical instruments, including lancets, sounds, catheters, forceps, and rectal and vaginal speculums. Despite Brahmanical prohibitions, he advocated the dissection of dead bodies as indispensable in the training of surgeons. He was the first to graft upon a torn ear portions of skin taken from another part of the body, and from him and his Hindu successors, rhinoplasty, the surgical reconstruction of the nose, descended into modern medicine. The ancient Hindus, says Garrison, performed almost every major operation except ligation of the arteries. Limbs were amputated, abdominal sections were performed, fractures were set, hemorrhoids and fistulas were removed. Sushruta laid down elaborate rules for preparing an operation, and his suggestion that the wound be sterilized by fumigation is one of the earliest known efforts at antiseptic surgery. Both Sushruta and Charaka mention the use of medicinal liquors to produce insensibility to pain. In 927 AD, 2 surgeons trepanned the skull of a Hindu king and made him insensitive to the operation by administering a drug called Samohini. Hospitals were erected in Ceylon as early as 427 BC and in northern India as early as 226 BC. For the detection of 1,120 diseases that he enumerated, Sushruta recommended diagnosis by inspection, palpation, and auscultation. Taking of the pulse was described in a treatise dating 1300 AD. Urinalysis was a favorite method of diagnosis. Tibetan physicians were reputed able to cure any patient without having seen anything more of him than his water. In the time of Yuan Shuang, Hindu medical treatment began with a 7-day fast. In this interval, the patient often recovered. If the illness continued, drugs were at last employed. Even then, drugs were used very sparingly. Reliance was placed largely upon diet, baths, enemas, inhalations, urethral and vaginal injections, and bloodlettings by leeches or cups. Hindu physicians were especially skilled in concocting antidotes for poisons. They still excel European physicians in curing snake bites. Vaccination, unknown to Europe before the 18th century, was known in India as early as 550 AD, if we may judge from a text attributed to Dhanvantari, one of the earliest Hindu physicians. Take the fluid of the pock on the udder of the cow, upon the point of a lancet, and lance with it the arms between the shoulders and elbows until the blood appears. Then, mixing the fluid with the blood, the fever of the smallpox will be produced. Modern European physicians believe that caste separateness was prescribed because of the Brahmin belief in invisible agents transmitting disease. Many of the laws of sanitation enjoined by Sushruta and Manu seem to take for granted what we moderns, who love new words for old things, call the germ theory of disease. Hypnotism as therapy seems to have originated among the Hindus, who often took their sick to the temples to be cured by hypnotic suggestion or temple sleep, as in Egypt and Greece. The Englishmen who introduced hypnotherapy into England, Braid, Esdale, and Elliotson, undoubtedly got their ideas and some of their experience from contact with India. The general picture of Indian medicine is one of rapid development in the Vedic and Buddhist periods, followed by centuries of slow and cautious improvement. How much Atreya, Dhanvantara, and Sushruta owed to Greece, and how much Greece owed to them, we do not know. In the time of Alexander, says Garrison, Hindu physicians and surgeons enjoyed a well-deserved reputation for superior knowledge and skill, and even Aristotle is believed by some students to have been indebted to them. So too with the Persians and the Arabs. It is difficult to say how much Indian medicine owed to the physicians of Baghdad, and through them to the heritage of Babylonian medicine in the Near East. On the one hand, certain remedies, like opium and mercury, and some modes of diagnosis, like feeling the pulse, appeared to have entered India from Persia. On the other hand, we find Persians and Arabs translating into their languages in the 8th century AD the 1,000-year-old compendia of Sharaka and Sushruta. The great Caliph Harun al-Rashid accepted the preeminence of Indian medicine and scholarship, and imported Hindu physicians to organize hospitals and medical schools in Baghdad. Lord Ampthill concludes that medieval and modern Europe owes its system of medicine directly to the Arabs, and through them to India. Probably this noblest and most uncertain of the sciences had an approximately equal antiquity, and developed in contemporary contact and mutual influence in Sumeria, Egypt, and India.